Hi guys, I am Boaz. I'm a mathematics and physics teacher. I've done mathematics, I've done physics at higher level. I have also done actuarial science from the University of Nairobi. So I've been teaching from middle school, high school, A-levels maths, even at the university. At the university I teach people who are taking the quantitative analysis and the quantitative techniques. The application of calculus in that brings a lot of fun to me because I've done maths for so many years and I even guide actuarial students in developing models. Now currently I have a company called DISNEYLAND Media International. We do the coaching, we do the mentorship. We also have some monthly conferences for students every last Saturday of the month. We use the premises around the outskirts of Nairobi. An example is the Oak Place in Runda Place and some of the hotels within the setup of Nairobi. So this our program has really been helping our students across from local schools, middle schools, all the way to international schools, even university students. So we come up with models, stuff like time management at school, even at home, how you study, your career life, some of the qualities of great students and what makes you great as we lead you leading to your career life. So today is not all about the talk. I want to teach you something about the sketching of the graphs. Our topic of today is going to touch most on the graph. How do we sketch a graph? And what is a graph? Because all of us, we know, we've learned about in the middle school the basic mathematics, where you have the x-axis. An example, if you have here, having the x and having the y-axis. And in my previous lecture, I'd already told you that y is always a function of x because it is x that is mapping to y. And we know y is always considered as the range, and the x, we consider it as the domain. Now, this y sometimes we'll note it with the f of x. So anytime you see the f of x, just know that y is a function of x. Just like somebody can come and give you y is 2x minus 1. So this x is independent variable, y is dependent. So that's why we refer to y as the range and x as the domain. And you know very well that both the x and the y, we call them the variables. Means they take different values. Now, when you know that particular basic, I'll use the knowledge in calculus to help you guys know how to sketch a graph. From sketching it, you can even determine the gradient at different points. So it means I'm going to a bit talk on what we call the derivative of a function, which I know from middle school you've already learned what the gradient of a line is. But as you go all the way to A levels, because these are the basics that will help you in the middle school, in your A levels, even in the campus. Because some of the students I usually teach basically doing their masters, like in the University of Nairobi and from Strathmore, I teach them quantitative analysis and quantitative techniques. And I find these basics from the middle school becomes very important. Remember, in maths, we build a culture step by step as we move forward. Now, when we have this, let me give you an example. If you have a function like y is x power n. Now, if you've been given that function, which is part of the polynomial, if somebody asks you to get the derivative, which is the gradient function, how do we get it? The gradient function is denoted by y prime, which is the dx of y. Means we are differentiating y with respect to x. And what do we get when we differentiate that? If we have y is equal to x power n, this implies our y prime becomes the nx power n minus 1. In other words, when you differentiate a function, the power multiplies the whole of it, then the power reduces by 1. Are we good? An example, if somebody provide y is equal to 2x squared, how do we get the derivative of that? We come and write that y prime becomes the power which is 2 times everything. 2 times 2x squared becomes 4x squared. But remember, the power reduces by 1. So we minus 1. So our derivative becomes 4x. If we add it, y is equal to 2x squared. Now that is the basic I wanted to introduce. Now let me give you an example how you get it. Now if somebody provide y is equal to x squared, let's make it x squared, minus maybe 6x plus 8. If somebody gives you that particular function, particular quadratic, for you to sketch it, because I know from the middle school you've learned about linear functions. An example, y is equal to mx plus c, where the maximum power was 1. Then they gave you an example, ax squared plus bx plus c is equal to 0. This was called a quadratic because the maximum power was 2. Then you are given ax cubed plus bx plus c is equal to 0, maybe x squared, cx, and all that. When the maximum power was 3, we call it a cubic. Okay? Then we have the quartic when it is power 4. Then quintic, power 5. So we move that way. But the most important thing is that you had already learned these basics in your middle school. Now, my agenda today is not to introduce all that. I'm just going to show you a very important concept, that how do we sketch a graph? Number one, you must know how to get the derivative of that function. We have our dy by dx. I'm differentiating y with respect to x. And as I said earlier, the power multiplies it, then it reduces by 1. So we are going to get the 2x, the power reduced by 1, minus 6. But remember, most of the times you've learned that when you differentiate a constant, you get a 0. So the d dx of this number, when I get the derivative of d dx of the number 8, I get a 0. That is a rule, that when you differentiate a constant, it becomes a 0. And the reason is very simple. This is like having 8x power 0, because x is not there. And we all know that all the numbers raised to power 0 is 1. So it's like 8 times 1, which is still 8. So when the power comes and multiplies it, it becomes a 0, when we talk in terms of the derivatives. Now, when we differentiate this, we get the 2x minus 6. Now let's walk with me. Now, after differentiating this, we always know that at the turning point, assume you have a graph. Let me explain it here. If this is x and this is your y, you have a graph of that nature, or maybe a graph of that nature. Remember, at this point, we call it the TP, the turning point. And at this point, we also call it the TP, the turning point. The lower turning point, we call it the minimum point. And the upper turning point, we call it the maximum point. Maximum means up. Minimum means down. Now, when you have this quadratic equation, remember very well that if you are to plot it, it would basically provide either the minimum or the maximum. So we always say, after getting our first derivative, at the turning point, which means if you draw a tangent, it is a parallel line to the x-axis, which means it doesn't have the gradient. The gradient is 0. So you come and say, at the turning point, the TP, the dy by dx becoming 0, which implies, based on what we've just done here, allow me to wrap this part. So we are going to take our 2x minus 6 is equal to 0. Then 2x becoming 6. We do the additive inverse. Divide both sides by 2, which cancel. This implies our x is 3. So it implies at the turning point, the x will be 3. And you know very well, many times you do in arithmetic, when you have the value of x, you can get y. Because from our initial equation, we were told y is supposed to be x squared minus 6x plus 8. And taking x to be 3, I will square 3 minus 6 into 3 plus 8. So this provides 9 minus 18 plus 8. So this provides 9 plus 8 is 17, minus 18 become negative 1. So it means at the turning point, the coordinate become 3, -1. So that's one of the most important things that you need to learn, that at the turning point, we already know the coordinates. The next point that we need to identify, that is part number 1. The concept number 2 that we need to learn is knowing what will be the coordinates at y-intercept. But remember, whenever a line cutting y, the value of x is 0. And at x-intercept, the value of y is 0. Now let's start with the y-intercept. Let's start with the y-intercept, or maybe we can just start with the x-intercept and say, when the graph will be cutting x, y will be 0. So you take your equation here, y equal to x squared minus 6x plus 8. At x-intercept, y is 0. So instead of writing this value of y, we write it to be 0. We write our x squared minus 6x plus 8 equal to 0. You can see what it has resulted in. That is now a quadratic equation. And I taught you guys that a quadratic equation is in which form? A quadratic equation is in the form of ax squared plus bx plus c is 0. How do we solve quadratic equation? We can solve quadratic equation by using completing square method, by using quadratic formula, by using product and sum, or by drawing the graph. Let us go the most easy way, by using the quadratic formula, which says if you want to get the x, it is always minus b plus minus the square root of b squared minus 4ac divided by 2a. So this is the quadratic formula that we want to use here to solve the value of x. Remember, all the times we go to the basics, you come and say it is in the form of ax squared plus bx plus c is equal to 0, which implies your a becoming 1, your b is minus 6, and your c is becoming 8. Now we substitute it in the formula, because in the formula we know that for you to know x, you simply take minus b, but remember it's a minus. So minus minus becoming plus 6. Then we go to the formula, we put the formula, b squared. So if you square negative 6, you get positive 36 minus 4ac. This is a c. So when you take 4 times 1, we get 4 times c, which is 8, we get a 32. We divide everything by twice a. Remember, our a is 1. So we get 2. You see how easy it is. Then we get 6 plus minus 36 minus 32 is 4. The square root of 4 is 2. So you put 2, divide everything by 2. So if you start with the plus, 6 plus 2 is 8. 8 divided by 2, we get 4. Then 6 minus 2 is 4. 4 divided by 2 is 2. So we have two values of x, which in quadratic equation we call them the roots. Now look here. We have clearly seen that the root, the first x is 4, the next x is 2. So we can get back our value of y, knowing very well that my y should be x squared minus 6x plus 8. Now we can easily find it here. We come and rewrite our y will be x squared minus 6x plus 8. So when I substitute it at 4, so I square 4 minus 6 times 4 plus 8. 4 squared is 16, minus 6 times 4 is minus 24. So 8 plus 16 is supposed to be 24. 24 minus 24 becomes 0. So that provides the y to be 0. So when x is 4, y becoming 0. Then we go when x is 2. We square 2 minus 6 into 2 plus 8. What is 2 squared? 2 squared is 4. 6 times 2 is 12. 4 minus 12 is supposed to be minus 8. Minus 8 plus 8 is 0. So those are the coordinates at when it is cutting x-axis. So when it cut x-axis, these will be the values. This is the value of x and the value of y. Then we have how many coordinates? Now we have this coordinate, we have that, and we had the one where we were working about what? Our turning point. So we already have the 3 turning points. Then we need to identify, is it supposed to be a maximum on top, or is it a minimum on the lower side? How do we get that? Listen to this. When you want to know whether it is a turning point, the turning point is the maximum or minimum, we must get the second derivative. What is the second derivative? The second derivative is differentiating your gradient function you've already differentiated. It's like differentiating twice. Now let me explain. You can come back here and say whatever we differentiated, our y prime, which we had differentiated, was supposed to be 2x minus 6. Then I'm going to differentiate it again. I get the dx of the dy by dx, which is supposed to be d2y by dx2. So when you differentiate here, what do you note? The derivative of a constant will be 0, so we are going to get a 2. What do you note? The number is what? A 2. But 2 is greater than 0. That one even in middle school you know. When you get a number greater than 0, so it becomes a minimum. You understand? A number greater than 0 is a minimum. But if you were to find a number less than 0, an example, a negative, it would have been a maximum. So basically speaking, when you want to sketch, this our sketch will look like. We are going to have our y, we are going to have our x. Then you plot it. You can have here to be 1, 2, 3, 4, 5, then all the way. Then we can have 1, 2, 3, 4, 5. We can also have the negative side and the negative on the y. Then let us start plotting. The point 3, negative 1 means x is 3, y is negative 1. So means on the lower side here. So it is somewhere there. Then we had 2, 0. So you come where there is 2, 0 is on the x-axis. Another point we had 4, 0. 4, 0 is at that point. Then we did not know, we were to ask, where does it cut y-axis? When it cut y-axis, the value of x is 0. Now, if you all know that our graph clearly says y is equal to x squared minus 6x plus 8, and when it cuts y, the value of x is 0. So replace this by 0, so means my y becoming 8. So when it is cutting y, it is somewhere there 8. Then how do we draw? This is now the sketch. This is now how we sketch our graph. You see, now it is the turning point on the lower end. And remember, many a times you want to sketch any graph, you must first of all understand, is it a cubic or is it a quadratic? Then remember to get the first gradient, the first derivative, get the second derivative, but equate your first derivative to 0 to provide the turning point.